So we just did a graph of a composition of a rigid motion and a dilation. And so now we're looking at we have a pre-image, an image, and we're going to see if we can come up with a composition. Can we describe a composition of a rigid motion and a dilation? So the question is there a composition of transformations that maps triangle XYZ, so this is our pre-image, to triangle JKL? All right, so let's take a look at things we notice. We notice that both triangles appear to be the same shape, but different sizes. So both triangles appear to be the same shape, but different sizes. So when we notice that, that means that we're probably looking at a dilation. So, yep, similar shapes, different sizes, probably a dilation. Can we figure out what the scale factor would be? Well, we can take aside, I think XZ is going to be the easiest one. So XZ will correspond with JL. XZ is from the pre-image, 1, 2 units long, and JL is 1, 2, 3, 4 units long. So our scale factor, you take the length of your segment in the image, which was 4, and divide it by the length of the pre-image, the corresponding side, which was 2, and we're looking at a scale factor of 2. All right, well, what else do we notice? We also notice that X maps to J, Y maps to K, and Z maps to L. And if we kind of notice how that happens, so here's X, it maps to J. Notice if I were to draw a line, it kind of goes right through the origin right there and like straight across. Y maps to K, so if I go from Y to K, again, I'm going through that origin, forming a straight line right there. Z maps to L, so from Z to L. And again, we can figure out which vertex that maps to which which vertex maps to which vertex from this right here. So Z maps to L, again going through the origin at a straight line. When we notice that that happens, we're looking at a possible rotation of 180 degrees. So it appears to be a 180 degree rotation. So it can be hard to kind of visualize that. So I'm going to insert a quick video just to show you how we do dilate and then do 180 degrees rotations to get this pre-image mapped onto this image. All right, so here we're looking at our pre-image XYZ and our resulting image JKL. We had just talked about there being a scale factor of 2, so I'm going to show you what the scale factor looks like. Right now the scale factor is set to 1, so if I just slide this over, I'm going to try to hit it. So you can see our image is getting bigger. I'm going to make it bigger all the way to a 2. There we go. And then I'm going to rotate it. Right now the rotation is 0, but I'm going to rotate it 180 degrees about the origin. So over here you can see it's rotating. I'm going to try to land on 180 degrees. Sometimes it's hard. Oop, went too far. 180 degrees. And we can see that we mapped it right onto JKL. So that was, we did a scale factor, or we did a dilation with a scale factor of 2, followed by a rotation. So that was a composition of a rigid motion and a dilation. So what if you had looked at this and said that you noticed the rotation first and the dilation second? So if we do the rotation, let's say we rotate it 180 degrees first, and then after that we do a dilation with a scale factor of 2, where your center of dilation is the origin. You can see how it's getting bigger to map right onto the resulting image. So you could write this composition 2 different ways.
All right, so our composition of transformations, here's kind of our final summary of all of this. We could write that we had a rotation of 180 degrees about the origin, composed with a dilation of scale factor 2. Now remember, that means you would do the dilation first and then the rotation. Or we could have done the dilation after we did the rotation of 180 degrees about the origin. Both of these will map triangle XYZ to triangle JKL.